Alright guys, the last thing that there is in this chapter is how to find, and the only math really in this chapter is how to find atomic mass. Okay, now we just had a video shortly ago on what isotopes were, and the fact that isotopes can have different numbers of neutrons. And the other day in class time, we talked about what the job of protons, electrons, and neutrons in an atom were. And we also talked about the mass of each one of those particles. And we talked about the mass of a proton. Oops, let me get a pen here. A proton has a mass of 1 AMU. Electrons have a mass of 1 over 1840. They're tiny little things. Tiny and quick. And the neutron has a mass of slightly over 1 AMU. It's the largest of the three subatomic particles. Okay, and remember, protons live in the nucleus. Electrons live in clouds or energy levels outside the nucleus. And then neutrons also live in the nucleus. And we talked about what each one of their purposes was. The protons, they identify what the element is. Electrons, they give it its chemical character or behavior. And then neutrons, they're the ones that it's their job to hold those protons tightly in place in the nucleus, and also to keep those electrons out of the nucleus. Alright, and so since they can have more or less neutrons, they cannot have more or less protons. The example that I used last time in the video was nitrogen. So let's keep up with that theme. If nitrogen has exactly 7 protons, then its nucleus has a mass of 7 AMU from the protons only. But let's talk about the neutrons. It can have a mass of either, let's say, 7 AMU from the neutrons or 8 AMU from the neutrons. Now, that's going to change its mass. That's going to change the mass of the nucleus. So how do you know what's the mass? Is it going to be 15 AMU or is it going to be 14 AMU? And how do they know what number to put on that chart up there? You notice on the chart in our classroom for nitrogen, that mass says 14.0067. Where in this world do they get that number? Well, they get that number from taking an average, okay? And each year when I teach this topic, this is how nerdy Misty is. Because when I come up with how to find student averages, I came up with how to find student averages from exactly this topic, from weighting them. And so the atomic mass of an element is, atomic mass of an, oops, that's supposed to say element, is the weighted average of its isotopes. Now, what they do is they capture a bunch of nitrogen, let's say, since that's the example we're using, and then they painstakingly figure out what percentage of that nitrogen that they capture is nitrogen 15 and what percent is nitrogen 14. So you can look at the periodic table and see, since the atomic mass that they put up there is 14.0067, obviously almost all the nitrogen that they capture out there in the universe is nitrogen 14. There's not very much that they capture that's nitrogen 15. And then what they do is they literally say, okay, please understand, students, please understand with me, I'm totally pretending here. 92%, I made that number up, guys, I made it up, is nitrogen 14. And then 8% is nitrogen 15. I'm going to give you real numbers to work with here shortly. We're going to get them out of the textbook, and they happen to be on page 114 in your book. So let's say that that's correct. So what you would do then is you would say, okay, well, nitrogen 14 has an atomic mass of approximately 14 AMU. So I'm going to say 14 times 92%. And what do we do with percents? Change them to decimals. 0.92. And then I'm going to say 15, and we're going to do that math. And then we're going to say 8% times 15. So 15 times, and we're going to change that 8%, 0.08 equals. We're going to get what that equals, and I'm going to get my handy-dandy trusty calculator. Put this down for a second. I'm going to get this trusty handy-dandy calculator. And according to my trusty handy-dandy calculator, 92 14 is 12.88. And then 15 times 0.08 is 1.2. And then what you do is you add those two. So this is an 8, that's a 0. Carry that 1. That's 2, 3, 4, 14.08. And you see that's off just a little bit from what's up on the chart. And that's totally, students, because I made those numbers up. In your textbook, which I didn't want to have to take time, because you can't see this on this iPad, I didn't want to take the time to have to find all those numbers and look them up for you, but I'm going to make a copy of your textbook so that you can actually see them. But that is exactly, and don't forget your units, so it's going to be -1. Multiply those out, and it gives you the percentages. You will never have to figure those out. I will give those to you, and it gives you the mass, the actual mass of each one. And sometimes it says negligible, and if that means that there's so little of it out there in the world that they can't even measure it. So it would be like 0, and you would say 0 times that. But this is a pretty close approximation of the mass of nitrogen, and that's what you would put up there. And if you were to look in the textbook on page 114, you're going to see that my numbers were wrong, because actually the actual percent of nitrogen is 99.63% of nitrogen 14 out there in the world, and there's less than 1% of the nitrogen 15 out there in the world. So that's how you find that, and you will be required to do that on your test. We're going to practice another one in class, and I hope y'all have a great week.